All right, so in the last video, we talked about adding, subtracting, and multiplying radicals. And then we know from the video or from the lesson before in 10.2 that we can't leave radicals in the denominator. So then the question becomes, how do I get rid of radicals if I can't add them together, right? So like, we're going to use what are called conjugates, but like this example on this slide, square root of 7 plus the square root of 3. If that was found in the denominator, I can't just multiply by 7 and I can't just multiply by 3. I definitely can't just multiply by a square root of 21. It won't get rid of anything that's in the denominator. So we're going to use what is called a conjugate. And so what a conjugate does is they're the sum and difference of two terms. So our square root of 7 plus our square root of 3. Its conjugate would be the square root of 7 minus the square root of 3. And what ends up happening with these is they become the difference of squares. So if you remember the difference of squares, that was when we had like, let's see, x plus 3 times x minus 3. And so that ended up giving us x squared minus 9. And so that's going to do the same thing for us here. So for example, if I were to take the square root of 7 plus the square root of 3 times the square root of 7 minus the square root of 3, what I end up with is square root of 7 times square root of 7 is 7. I would end up with the square root of 21 minus, right? So 7 times 7, 7 times, well, I guess this one would be my negative 21. So 7 minus the square root of 1 plus positive 21, so square root of 21, and then we'd end up with minus 3. So our middle terms cancel out, leaving us with just 7 minus 3, which is 4. And so then I now have a number on my denominator and no square roots because our middle terms will always cancel out. So we really just have to worry about the outsides, and it will always be a minus. So it's that difference of perfect squares. All right, so let's actually use conjugates. All right, so rationalizing our denominator using conjugates. I'm going to rewrite this so that it's more the size that we're easy to work with and write next to. All right, so I cannot just multiply by one of my square roots, and so what I'm going to multiply by is the conjugate of the square root of 7 minus the square root of 2, which would be the square root of 7 plus the square root of 2, and when I multiply the denominator by, I have to multiply the numerator by. So on the top, right now, I'm just going to leave it as 10 times the square root of 7 plus the square root of 2. And then on the bottom, like we said before, it's going to be a minus between them. The square root of 7 times the square root of 7 is 7. Square root of 2 times the square root of 2 is 2. So 7 minus 2 is 5. So we end up with a 5 in the denominator. Just remember, the reason I'm not going through and doing those two middle terms is because I already know that they're going to cancel out. So that's the whole purpose of making sure that we have those different signs. It's the different signs that make those cancel out. Now, I do know that 5 divides into 10, so I'm going to divide into that evenly. And so now I have 2 times the square root of 7 plus the square root of 2, and then I'm going to distribute that through so that our final answer is 2 square root 7 plus 2 square root 2, and that is our final answer. So again, we multiply by the conjugate, which just means I am changing the sign between my radicals. So we started with a negative. I made it a square root of 7 plus a square root of 2. What I multiply the denominator by, I have to multiply the numerator by. Because we have the different signs, I really just have to worry about taking my first terms times each other and my last terms times each other. It will always be a subtraction in the middle. And then I just simplify from there. All right. Let's use we're going to dive into some math in nature. So fiddlehead ferns naturally grow in spirals that fit into what are called golden rectangles. What is the width of the fern shown? So other information that was in the book that would be helpful. Golden rectangles appear frequently in nature and art. The ratio of the length to the width of a golden rectangle is 1 plus the square root of 5 to 2. So that's our ratio. We have our length over our width. So when I set this up, I know that my length is 4 centimeters, so that's going to go on top. And my width is just W. I don't know it yet. So then from here to solve for W, we're going to cross multiply. So I'm going to have W times 1 plus the square root of 5 equals, and then 4 times 2 is 8. Now from here I need to get W by itself, so I'm going to divide by 1 plus the square root of 5 on both sides. And so over here I have that W equals 8 over 1 plus the square root of 5. Now the issue is that the square root of 5 is in the denominator, and we're now going to have to rationalize that out. And so we are going to multiply both top and bottom by 1 minus the square root of 5, because that is the conjugate. And so when I do that, I end up with 8 times 1 minus the square root of 5 over, and then 1 times 1 is 1. We're going to minus, and square root of 5 times square root of 5 is 5. So now we're going to end up with 8 times 1 minus the square root of 5 over negative 4. Negative 4 goes into 8, negative 2 times. So now we have negative 2 times 1 minus the square root of 5. Distribute that through, and I'll end up with a negative 2 plus, because negative is positive, 2 square root 5. And then that, I say that's our final answer, but it does say later on, I think I forgot to write it in, that it wants us to round to the nearest tenth. So when we do, it started to look like a fraction, we don't want a fraction. When we do that, we're going to be approximately 2.5 centimeters when we plug that into the calculator. And really all that is plugging that into the calculator and rounding. And that is how we conjugate radicals. I will see you in the next video, or talk to you in the next video, when we actually start solving equations. So far we've only worked with simplifying expressions. Our next video we're going to start working with radical equations. I'll see you there.